Today we are starting Unit 1, Lesson 4. The learning target is I can find the missing side lengths and angles of similar figures by using the angle, and proportional side criterion. You do now is, what is the solution to the equation below? I would like you to pause your computer and to work this, and then I will come back and we will go over it. So when we use our checklist that we've had posted, our first step is there distributive property? Yes, there is. We can tell because of the parentheses. So we're going to distribute the 3 to the x and to the 4. So I'm going to distribute again the 3 to the x and the 3 to the 4. 3 times x is 3x. 3 times 4 is 12. And we have 3x plus 4. We could tell this is a no solution because it has the same coefficient and same variable. And if you to bring it to the other side, they would cancel out and you would have no variable to solve for. So this is a no solution. That's how we could tell quickly. But if you're not sure, you can actually start solving. So using inverse operations, I'm going to subtract 3x on each side. And now we get 12 equals 4, which is not true. And that's why it's no solution. Now I would like you to take the next one, which is 8 times 2x minus 4 equals 2 times 4x minus 16. So the first thing we have to do here is do the distributive property again. So I'd like to do my arrows so we don't forget to distribute the outside number to each element on the inside. I want you to pause your computer and you try it. So if we are to distribute, 8 times 2x is 16x. 8 times negative 4 is negative 32. Equals 2 times 4x is 8x. And 2 times negative 16 is negative 32. Right before I even move on to solve this, I can already eliminate 2 answers. Because 16x and 8x are 2 different coefficients but same variable. That's a 1 solution. So no solution is already eliminated and infinitely many. So now we have to see if x is equal to 0, x is equal to 10. So using our checklist, we did our distributive. Next is to combine like terms. Are there variables on both sides? So we take the smaller coefficient to the larger coefficient by using inverse operations. So I'm going to subtract 8x on each side. And I get 8x minus 32 equals negative 32. Now we have to isolate the variable, so I'm going to move the constant of 32 to the other side. And because it's going to the other side, inverse operations, and minus of 32, now I'm going to add 32 to each side. So now the subtraction of 32 and the addition of 32 are opposites. They cancel out. So we get 8x equals, again, negative 32 plus 32 equals 0. We are not done yet because we did not isolate the variable. So you divide each side by 8. And x equals 0 divided by 8 is 0. So it is choice B, and x can be 0. Okay, so now we're going to go to our next slide. And we have this launch. Number 1, we have 3/12 equals x over 36. This is set up as a proportion. So now how do we solve it? Yes, we use cross products. So some of you will call it the butterfly method. We call it cross products in 8th grade. So now we do 12 times x gives you 12x equals. Please do not forget your equal sign. And then 3 times 36 is 108. Now we have to solve for x. We isolate the variable. We have to divide by 12 because this is 12 times x. The inverse of multiplication is division. 12s cancel out, and x equals 9. Record. Number 2, the following triangles are similar. With a partner, well, we can't do partner right now because we're on video. Discuss what it means when figures are similar. You can use the example right next to this box that's asking the question. And you could see similar is same shape, but not necessarily the same size. So we could see these two triangles are the same shape, but they're not necessarily the same size. As you could see, I labeled or I colored the corresponding sides, which means the same position in the same color. So we know that corresponding sides are in proportion. And what do we mean by corresponding? They hold the same position. So the 15 holds the same position as the 10. They correspond. The x corresponds to the 8. So because they're in proportion, corresponding parts, or the corresponding sides, that's why we set up a proportion to solve this. So we could do the height to the base. Sorry about the technical difficulty. So we could set it up as a proportion, the height to the base, height to the base. Just as long as these two are equal, they have to be exactly the same. That's what a proportion means. Both sides are equal to each other. So I'm going to substitute. 15 is my height because that's how tall the triangle is. We're looking for x, that's your base. And the next one is the height is 10 and the base is 8. We also could set this up as height to height and base to base. And you set them up equal. And again, this proportion will work out because height to base, you have height to base, height to base. I'm going to put in those numbers showing you that we're going to solve both of them. This way you could see it works out just as long as your proportion is set up correctly. So we can have 15 is to 10 as x is to 8. Yes, we use cross products to solve it. So we get. So what happens here, I'm going to extend my page. 10 times x is 10x. 15 times 8 is 120. We have to isolate the x. It's multiplication between the 10 and the x. So my inverse is division. And we get x equals 12. Well, let's see if this one comes out to the same. So here we go. We could do again cross products. And you get 10x equals 120. Divide by 10, and x equals 12. So you could see, if you set it up height to base, or height to height, base to base, it comes out to the same answer. So now we're going to go to the next slide. And now we have here triangle ABC and triangle DEF are similar. What do you notice about the shape and size of the two triangles? Well, based on what we did on the previous slide, we know they're the same shape, but not the same size. So we write the same shape, different size. So, what angle corresponds to angle D in the larger triangle? When we look at the word corresponds, we mean it holds the same positions. So I'm going to write same position. They're in the same spot. So I look at angle D, it's at the top. What corresponds to it? Angle A. It's in the same position. And we use this little um, arrow which means angle. So it's angle A. Now they want to know what angle corresponds to angle E in the larger triangle. Well, look where angle E is, and because it has a little box, we know it's a right triangle, and a right triangle equals 90 degrees. We have angle C is also a right angle, so it's holding the same position. What angle corresponds to angle F in the larger triangle? Angle B. Now, they said that the measure of angle A is 53 degrees. What is the measure of angle D? Well, because we know that they are in the same position, even though the triangles are different sizes, the corresponding angles are congruent, which means equal. So what is the measure of angle D? It is going to be 53 degrees. Let's find the measure for angle C. Well, we see the little box. And we know that the little box means it's 90 degrees. It's a right angle. So find the measure of angle E. Since it holds the same position, we know it's the same number of degrees. Now our problem is, what is the measure of angle B? Oh my goodness. So you look at this and you know a triangle is equal to 180 degrees when you add up all the angles. So I know I have 53. I know I have 90. So you add those two together, you get 143. Now you have to take the difference because the total of a triangle when you add up all three angles are 180, and you subtract the 143 and you get 37 degrees. So I know angle B is 37. So if angle B is 37, who corresponds to it is angle F. They want to know what is the measure of angle F, and it is 37 degrees. So let's do a little mid-lesson summary. We have to use our prior investigation to verbalize what you know about angles and sides, lengths of similar figures. What do you know about corresponding angles in similar figures? We know the word corresponding means same position. And when they hold the same position, we saw that they are the same number of degrees. So we know that corresponding angles are congruent. That's our special word. And this is the symbol for congruent. It's a squiggly line with an equal sign. And that means they are equal in measure. Same number of degrees. Now, the next one says, number 2, what do we know about corresponding side lengths in similar figures? So corresponding means they hold the same position. And we saw from our previous example, where you had 15 is to x and 10 is to 8, that their side lengths, corresponding side lengths, are in proportion. So corresponding side lengths are in proportion. Okay, so let's go to the next slide. Remember, two figures are similar if they are the same shape, not necessarily the same size. The angle-angle similarity theorem says if two angles in one triangle are congruent to two angles in another, then the triangles are similar. So we could have saw, I'm going to go back to the example we used. We knew that angle A was 53 and angle D was 53. We knew angle C was 90 and E is 90. Right away, if two angles are equal to each other in similar figures, corresponding angles are equal, you know they're similar because the third angle, you're going to get the same number when you subtract it from 180. Now also, in similar figures, all corresponding angles are equal. That means they have the same number of degrees. Similar figures, all corresponding sides form equal ratios. So now I'm going to go back to the previous example. I'm going back to our original. Well, let's look here. The first one, number one, 3 over 12 equals x over 36. We knew that x was 9. So, what did you do to your numerator, 3, to get the numerator of 9? You multiplied by 3. What did you do to the denominator of 12 and multiplied by 3? You got the denominator of 36. So this one has an equal ratio of 3 to 1, or the scale factor is equal to 3. Let's look at the other one. So we saw here, we had 15 and 10. Those are the corresponding side lengths. And then we had x, and there's 8. Now we have to figure out what its equal ratios are. And what you could do, you take the height to the height, 15 is to 10, and then we have 12 is to 8. Well, you can't figure out right away what you do to the 15 to get to the 12, or the 10 to the 8, but you can reduce each fraction. What number goes into 15 and 10? The number 5. So this reduces to 3/5. Let's reduce 12/8. What is their common factor? And their common, or at least the factor, is 4. So 12 divided by 4 equals 3, and 4, oh, and I'm sorry, I made a mistake. When I divided the 10 by 5, it should have been 3/2. Sorry. So this equal ratio is 3/2. Little mistake there. And now 8 divided by 4 is 2. And there are their equal ratios, 3 over 2 and 3 over 2. So let's look at the next slide. The triangles given below are similar. Find the missing side. So I'm going to pause, and you have to find the missing side of both examples, and then when you're done, come back and we will go over it. Okay, so you should have set up proportions because corresponding sides, same position sides are in proportion. I'm going to do 3 is to 4. Hold on, my pen is not working. So I'm going to do height to base, height to base. I like to write my proportion out so I make sure I substitute correctly. And we call this a starter ratio. So my height is 3 is to 4 because that my base is 4. My height here is x and my base is 10. We do cross products and we get 4x equals 30. You have to divide each side by 4 and x is equal to, oh my goodness, 4 doesn't go exactly into 30. So you could say to yourself, all right, how many 4s are in 30? We know there are 7 and 2/4 left over, or 7.5, or 7.5. Now let's look at the next one. Find x. So I'm going to do 10 is to x, slant to the side, slant to the side. You're going to cross multiply or cross products, which we like to use better in 8th grade. We get 400x equals 2,800. Divide by 400 because I'm isolating my x, and x is equal to 7. Okay, a mid-level assessment. So I would like you to pause and take this assessment and come back and we will go over it. If you are having difficulty to answer this, if you look, I marked the corresponding sides with colors. So you know which sides are in the same position. So let's go over this. Given that triangle ABC is similar to triangle XYZ, which is not true, you have to circle the word not. Because if you don't, you will forget about it and you'll pick the ones that are true and you're not answering the question. Which is not true of these triangles? So looking at my colored sides, that should help you. The measure of angle Z is 65. Since we know they're similar, corresponding angles are congruent or equal in measure. The little box means that it's a right angle, so it's 90 degrees. Now, how can I find angle B? Well, we know a triangle is 180 degrees. So you're going to add up the 90 and the 65. So 0 and 5 is 5, 155. You subtract that from 180, and you get 25. So we know B is 25. And look at that. B and Y hold the same position, so it's 25. So we know angle Z is 65. They're asking for what's not true, so this is not the multiple choice answer. BC, which is in red. Now look how I put the colors. R for red. YX. No, sorry, YZ. YZ is red. Okay. BA. BA is blue. And XZ is yellow. Red to red, this should be blue to blue. This is not true, so this is the answer so far. Let me show you this. YC is not the answer. BC is red. YZ is red. BA is blue. And YX is blue. So they're equal. Red, blue, or you can go red, red, blue, blue. So this is not the answer because this is true. They're asking what's not true. BC is red. YZ is red. AC is yellow, and XZ is yellow. This is true. They're asking what's not true. So red, yellow, it's equal. Red, yellow. These are true. They want to know which is not, so it's B. So now I would like you to pause and try this out. And if you need to, if you want to label your sides with colors, the corresponding sides, it will make it easier for you to see. Okay, let's see. As you could see, I labeled the corresponding sides in the same color. The measure of angle C is 25 degrees. B is 85 degrees. Oh, I don't know what A is. Well, we know a triangle is 180 degrees. So we add the 25 and the 85, and you get 110. You subtract it from 180 degrees because the triangle is 180, and you get 70. So we know angle A is 70. Now, angle Z corresponds to angle C. They hold the same position. So if this is 25, this is 25. Angle B corresponds to Y. So we know this is 85. Angle A is 70. We know X corresponds to it, so it's 70 degrees. Find the measure of YX. They want us to find this yellow. Find the yellow one. So I'm going to put an N there because we don't know we put a variable because we don't know. It's an unknown. I'm not using X because X is on the triangle. How do we solve this? We have to set up a proportion. Well, I could see the blue to the blue, yellow to yellow. So 6 is to 4. I'm doing blue, yellow. And 12 is to N. Now we're going to do cross products. 6 times N is 6N. Equals, please do not forget your equal sign. 4 times 12 is 48. Divide by 6, and N is 8. Now we're going to go on to the next slide, and we have to try this one out. First, I would like you to do the smaller to the middle one that's in your packet. Solve for X and Y, and then I will bring out the other one for you to do. So I'm going to pause. Okay, as you could see, I labeled my corresponding sides with colors so I could follow it. It makes it easier for your eyes. So I did green to solve for X. I did green to green, 12 over 36, and then I did yellow to yellow. 3 is to X, cross products, and I got 9. Now I put the 9 under the X position. I had to solve for Y. This time I did red to red, 17 is to Y, equals, and I used a green to green. You could have used yellow to yellow, 3 is to 9. And I did 12 is to 36, cross products, Y equals 51. Now I want to move this, and I would like you to go from the middle one to the larger one and solve for Z and W. So now what you could do, you can color your corresponding sides the same color, so it's easy to set up. So let me put 51 here for Y, and I'm going to pause and then come back and we'll go over it. Okay, so now I labeled the corresponding sides. I had to solve for Z, which turned out to be 144. I did. 36 is to Z, they hold the same position, green to green, and 51 to 204, because I knew Y was 51, and that's red to red, and I got 144. Then we had to solve for W. I did 9 is to W as 36 is to 144, and we got W equaling 36. Okay, next slide. What are the key strategies I can use to find missing angles on the side lengths of triangles, determine if the triangles are similar? We know that corresponding angles are congruent. They hold the same position, same number of degrees. And we know the corresponding sides are in proportion. Okay, let's do our exit slip. I'm going to pause and give you a few minutes to do it. All right, we're back. Triangle M is similar to triangle N. Triangle M has two angles with measures of 32 degrees and 93 degrees. Which two angle measures could be included in triangle N? Well, we know that angle A corresponds to E, so corresponding angles are equal in measure, so we write a 32. We know B is 93. F corresponds to B, so we know that's 93. So now we need to find angles C and D. First, you have to find the three angles of the triangle. We know a triangle is 180, so let's add the 32 and the 93, and I get 125. Subtract that from 180, I get 55 degrees. So C is 55. Now I can assume D is 55. Well, let's see. 32 and 58. 32 is there, but 58's not. Not the answer. 32 is degrees in B, but 74 is not. 93 and 55. 93 and 55, and there are your choices. 93 and 87. 87 is not in the triangle. So that's why it's choice C. And that is the conclusion of our lesson.